Link Aggregation Control Protocol. In the process of networking, wired and wireless both are useful methods. However, wired methods are proven more effective than wireless. But while networking, it's troublesome to manage many wires at once. To solve this problem, link aggregation plays a vital role, since it's known to carry multiple ports collectively as a single channel. In other words, link aggregation combines multiple physical ports as one port, which makes it easy to carry out the task by the user. Also, it makes the process cost-effective. The Link Aggregation Control Protocol provides an effective method for bundling several physical links in a single logical link, which enables a network device to create an automatic aggregation of links, and also includes the transmission of LACP packets to the different network devices and implementation it through Direct Connect device. Mainly, it improves the bandwidth and resilience of Ethernet networks. With the use of link aggregation, the idea of integrating several physical connections into one logical connection can help in developing more durable communications. This article will focus on the LACP or Link Aggregation Control Protocol. We will go through its architecture, its working procedure, and its use in computer networking, as well as how to configure the LACP and its advantages. Link Aggregation Control Protocol. LACP is an IEEE standard, which is a part of the IEEE 802.3 AD specification. It allows the user to combine numerous physical Ethernet links into one logical link, which helps create load balancing in the interfaces. LACP Ether channel can be configured with a maximum of 16 Ethernet ports of the same kind. In that case, only up to 8 links in the link aggregation group will be activated, while the remaining 8 links will be on standby mode. In the process, link aggregation takes place through two different modes, active or passive. Both are briefly explained below. Active. To form an LACP connection, this interface keeps sending packets actively. Passive, on the other hand, in the passive mode, the interface can give a response to LACP but cannot initiate itself. Structure of LACP. Link aggregation applies to any three bottom layers of the OSI model. Here, power lines and wireless network devices, which combine multiple frequency bands, can be a good example of link aggregation at layer 1 or the physical layer. In layer 2, it usually happens between the switch ports, for instance, Ethernet frame in LAN or multilink PP in WAN, data link layer, or Ethernet MAC address, which can be either virtual or physical ports. In the network layer or layer 3, it can use the round-robin scheduling. For aggregation at layer 3 of the OSI model, hash code computed from fields in the packet header or combining both methods can be used. It can maintain the balance in network load across all links, regardless of the aggregation layer. However, it may not be used in some cases to avoid out-of-order delivery. In most cases, the failover is also included in this kind of method. In the process, combining is possible only if either the majority of interfaces are sharing the same IP address or the other way is when each interface has its address. Here, the first one may need both ends of a link to share the same aggregating procedure, but it is considerably better in terms of performance. On the other hand, load balancing divides the traffic across the interfaces based on the network socket or layer 4. Besides, the channel bonding indicates a lower-level division of traffic between physical interfaces, either based on the per packet or the data link. Features of LACP. The maximum range of a valid number of ports is 1 to 8, which are used in the channel. To send LACP packets with multiple grouping, the MAC address 0180C2000002 is used. During the process of LACP detection, the LACP packets are sent every second, and also the keep alive mechanism for link members can work faster by the 1 second and slower by the 30 seconds, which is set by default. The option of load balancing mode is also available, which can be selected in some cases, but not necessarily at all. The LACP mode contains two main modes, active and passive. Active mode helps the LACP to run indefinitely. On the other hand, the passive mode can activate LACP only once the LACP device is found, which is also a default setting. Standardization of the linked aggregation. The standardization of the linked aggregation includes the two main standards of linked aggregation control protocol. 1. The 802.3 ADD IEEE linked aggregation. The IEEE 802.3 ADD of linked aggregation makes it easy for the users to group Ethernet interfaces at the physical layer to create a single link layer interface, often known as a lag or bundle. Sometimes the user needs more bandwidth in the network, which is not possible with a single Ethernet link. However, a high-speed gigabit Ethernet link can be very expensive. On the other hand, using IEEE 802.3 ADD link aggregation can be a good solution. It can increase port density and bandwidth at a very less cost. Take an example. Suppose there is a need for 450 megabits per second of bandwidth for data transmission, but there is only a 100 megabits per second Ethernet link available. In this kind of situation, it is more convenient to create a lag bundle of 5 100 megabits per second fast Ethernet links than to buy a single Ethernet link. As for functionalities, the linked aggregation provides protocols and procedures and manages the objects to allow one or more parallel instances of full duplex links to be aggregated together to form a linked aggregation group or lag. 2. The 802.1ax. The IEEE 802.1ax 2008 is an upgraded version of 802.3 ADD IEEE standard, which is usually used to bundle up the multiple network connections into the parallel full duplex point-to-point link, which can be used as a single point link. This kind of linked aggregation provides a higher availability and transmission speed than the conventional connection. How to configure LACP? First of all, enable the LACP and then configure the per port specific LACP either in active mode or passive mode. Usually, the range of group numbers goes from 0 to 7. In the second step, the user needs to set a timeout for the LACP session, which defines the amount of time that a port channel will wait for a LACP before terminating the LACP session. It can go 3 seconds shorter to 90 seconds longer. The third step is to set a priority value. It can be high or low accordingly. By default, it is 255, but the range can go higher to 1 to 65,535. View the LACP configuration. Benefits. Increased bandwidth. The main advantage of the linked aggregation control protocol is that it is capable of combining multiple links into one logical link, which helps increase the bandwidth of the network. Automatic occurrence of failover and failback. Once the link failure occurs, the traffic under the failed link then automatically turned on to the other available links, which makes it a reliable method for data transmission. Cost-effective method. Linked aggregation is a cost-effective method. It combines multiple links into one, which makes it less costly and reliable at the same time. Less drain on the network address pool. The whole aggregation process can be assigned one IP address, which makes it a less confusing and time-saving method.